Alright, so we're going to look at how to do a simulation using Quartus 9.0 Service Pack 2, which I believe is superior to Model Sim and other simulation programs you may have at your disposal. Let's see how easy it is. Let's go to New Project Wizard. Here I have the directory, so I browse to the directory. In this case, it's already there. Let's just take that file. I'm using the same file that I'm using for the example in the lectures for a state machine. Viterbi control. I'm just going to add it as a file. Okay, and I'm just going to accept whatever it is they give me. Maybe I will, just to make sure that we've got the license, I'll choose whatever cyclone. It doesn't really matter which. I'm not even choosing the device. I don't care, because I'm not going to compile all the way. I'm just going to do a synthesis and simulation. Then I do that and that and that. Okay, I got a project. As you can see, I didn't even choose the device. One thing I need to do is to change this from Verilog 2001 to System Verilog 2005. Otherwise, you will get errors for any System Verilog construct that you use that is not supported by Verilog 2001. Now let's just synthesize. So this is start analysis and synthesis. Okay, so okay, no errors. Great. Now I'm going to do a new file, vector waveform file. Now what I do is, in this case, I am going to add all the inputs first. Alright, I'm going to add all the inputs. Okay, and then the buses I will add as a group. So I've got the inputs here, hexadecimal, sounds good. And I'm going to add now the outputs. Sounds good. Right? Got everything, I believe. Okay. And there is one more bidirectional. There's a bidirectional pin here. Just going to add all of these. Let's just add them like this. Okay. And really what I need to do, let's just simulate a write in this case. Let's just put a clock here. Clock. The timing really does, like the absolute number doesn't matter, because we're just doing a functional simulation. So I'm just going to get the default of 1 nanosecond per clock. Address, let's just give it a, I don't know, let's just give this a 7. Why not? Now in data, let's give it some value, some arbitrary value. I don't know. Let's decide on, I don't know, 80. Okay. Let's say that it's a write. Okay, it's a write. And let's give it a reset here. I wonder, is this reset active high or active low? Let's take a look. It is active low. Okay, well, no problem. All I need to do is invert it. Great. Let's give it a start here with turbinum. I don't know, let's give it a, just for fun, let's change it to 1. Alright, let's save it. The default as viterbicontrol.vwf. Now we go to tool, processing simulator tool. For some reason, this is in the processing menu, even though it's a tool and there's a tools menu. Go figure. But anyway, go to simulator tool. Very important to change this to functional, because we're only doing a functional simulation. We're not actually doing a timing simulation, which would be after compilation. And we generate a functional netlist. Great. Press start. Then we open this again. And voila, we have everything here. The bidirectional pins, as you can see here, we have, this is the actually when we were driving the bidirectional pins. So we can maybe group them. Let's group them. Sure, no, that's out. Sure. So, oh, and we can see we should have AB going out, so probably the bit order is reversed, so let's just reverse that. There we go, we've got AB. Voila, it's been a simulation, and it's exactly 5 minutes and 9 seconds on the clock, which I have here recording the video. So as you can see, it's easy, it's simple. I believe it's simpler than Model Sim. It's mixed language, accepts Verilog and VHDL. Just great.